September the 2015 lunar eclipse. This video compresses information gathered from Wikipedia in video format. Studies prove that reading while listening improves comprehension, increases speed as well as expands vocabulary and enhances fluency. Video sections: abstract, background, visibility, timing, gallery, supermoon, related eclipses, external links. Give your feedback on the comments section. Support the channel by subscribing and liking the video. Thanks. Abstract. A total lunar eclipse took place between September 27 and 28, 2015. It was seen on Sunday evening, September 27, in the Americas, while in Europe, Africa, and the Middle East, it was seen in the early hours of Monday morning, September 28. It was the latter of two total lunar eclipses in 2015, and the final in a tetrad, 4 total lunar eclipses in series. Other eclipses in the tetrad are those of April 15, 2014, October 8, 2014, and April 4, 2015. The moon appeared larger than normal, because the moon was just 1 hour past its closest approach to Earth in 2015 at mid-eclipse. Sometimes called a supermoon, the moon's apparent diameter was larger than 34 feet viewed straight overhead, just off the coast of northeast Brazil. The total lunar eclipse was darker than expected, possibly due to ash left behind from eruptions of the Calbuco volcano in April 2015. Background: a lunar eclipse occurs when the moon passes within Earth's umbra, shadow. As the eclipse begins, Earth's shadow first darkens the moon slightly. Then, the shadow begins to cover part of the moon, turning it a dark red-brown color. The moon appears to be reddish because of Rayleigh scattering, the same effect that causes sunsets to appear reddish, and the refraction of that light by Earth's atmosphere into its umbra. The following simulation shows the approximate appearance of the moon passing through Earth's shadow. The moon's brightness is exaggerated within the umbral shadow. The northern portion of the moon was closest to the center of the shadow, making it darkest, and most red in appearance. Visibility: the eclipse was visible over Europe, the Middle East, Africa, and America. Timing: the moon was not visible during this part of the eclipse in this time zone. Asterisk: the penumbral phase of the eclipse changes the appearance of the moon only slightly and is generally not noticeable. The timing of total lunar eclipses are determined by its contacts. Gallery: the stages of the lunar eclipse from Staffordshire, UK. Time-lapse images from Oslo, Norway. Time-lapse images from Bregenz, Austria. Warsaw, Poland. 2:01 to 2:16 Coordinated Universal Time. Denver, Colorado. 2:15 Coordinated Universal Time. Fray Bentos, Uruguay. 2:28 Coordinated Universal Time. Tampa, Florida. 2:30 Coordinated Universal Time. New York City, New York. 2:36 Coordinated Universal Time. Wrocław, Poland. 2:36 Coordinated Universal Time. Zurich, Switzerland. 2:36 Coordinated Universal Time. Coralville, Iowa. 2:52 Coordinated Universal Time. Munich, Germany. 2:55 Coordinated Universal Time. Sisha, Greece. 3:01 Coordinated Universal Time. Berlin, Germany. 3:05 Coordinated Universal Time. Mill Valley, California. 3:07 Coordinated Universal Time. Munich, Germany. 3:23 Coordinated Universal Time. Boston, Massachusetts. 3:24 Coordinated Universal Time. Germany. 3:37 Coordinated Universal Time. Cône-Cours-sur-Loire, France. 4:02 Coordinated Universal Time. California. 4:07 Coordinated Universal Time. Supermoon. This eclipse moon appeared 12.9% larger in diameter than the April 2015 lunar eclipse. measured as 29.66 and 33.47 in diameter from Earth's center. As compared in these simulated images, a supermoon is the coincidence of a full moon or a new moon with the closest approach the moon makes to the Earth on its elliptical orbit, resulting in the largest apparent size of the lunar disk as seen from Earth. This was the last supermoon lunar eclipse until the 31st of January 2018. Related eclipses. The eclipse was one of 4 lunar eclipses in a short-lived series at the descending node of the Moon's orbit. The lunar year series repeats after 12 lunations, or 354 days, shifting back about 10 days in sequential years. Because of the date shift, Earth's shadow will be about 11 degrees west in sequential events. A lunar eclipse will be preceded and followed by solar eclipses by 9 years and 5.5 days. A half Saros. This lunar eclipse is related to 2 annular solar eclipses of solar Saros 144.